my name is Katie Moussouris. I'm a Senior Security Strategist here at Microsoft. I'm here with Ian Helen, a Senior Security Engineer, also with Microsoft, who's joined us at BlueHat. I believe this is your first time speaking at BlueHat, is that right?
I think it is.
All right, well, we're happy to have you, and I'm curious to know, and the viewers are curious, what is it that you'll be speaking about at BlueHat?
Okay, well, the problem we're trying to deal with, my department looks after reviewing Windows, kind of doing security reviews on Windows components. And the problem we often have to deal with is just the vast quantity of Windows code. So there could be maybe 4,000 or 5,000 binaries in a given Windows release. Mm-hmm. Which do we decide needs special attention, which are high risk? How do we even find our way around the whole operating system? So my talk's about trying to build a map inside of Windows based on its security attributes, security, things like security risk, code age. Mm-hmm. So to try and identify which are the high-risk components that we want to spend more time reviewing.
So what are some of the factors that go into deciding what constitutes a high-risk Windows component? Or I guess for the general audience, any software component?
Okay, that's a good question. It turns out there are a few factors. One of the ones I've concentrated on most is the particular behavior of a component. So if you look at maybe in terms of the API calls that it's made to the Windows 32 API, you can see perhaps whether it opens a network socket, whether it reads a file, whether it does any encryption operations, authentication, this kind of thing. So that tells you something about if a component is doing those kind of things, it's likely to be opening up some avenues of attack, or it's providing some kind of security guarantees if it's doing encryption or authentication. So that's one of the factors, and we can look at that and kind of provide a measurement of that across either just scanning the source code or during compilation. We can kind of dump all of this information. Second factor is really the code quality. So if even though somebody might be using network APIs, might be opening up attack vectors, as long as they've validated all the input, mm-hmm. done authentication properly, as long as the quality of the code is good, then there probably isn't a vulnerability there. We might still want to look at it, but our confidence is going to be a lot higher. And this is a bit more nebulous, trying to work out code quality. So there are some metrics that I've been trying to use, like things like average code age mm-hmm. of a given component. So if something, particularly there's a lot of code that was written maybe 5 or 10 years ago before
the SDL.
Yeah, before there was a lot of emphasis on security as a big factor in writing your code. Mm-hmm. Then that would make us more suspicious, more likely to have a look at it. There are some other things like code complexity. Mm-hmm. So the more complex, maybe the more source files, the bigger the source files, bigger the functions are within a source file, then perhaps there's more avenue for developers to make mistakes. We also have tools that kind of do automatic scans on all of our code, and these produce a lot of warnings about potentially unsafe constructs. So we can use things from these tools to indicate that this might be an area we want to look at.
So you're looking at beyond banned APIs, right? You're looking at unsafe constructs. Can you
yeah.
explain a little bit more?
So
about
these are perfectly legal APIs. Mm-hmm. So let's take an example like say a component registering an RPC interface. Mm-hmm. Something that a lot of Windows components do, and we can look for calls where the component's made a call to register that RPC interface, and we can also tell certain things about it by looking at the parameters. We can see whether it's set up to receive only local calls on the machine, mm-hmm. in which case we give it a relatively lower score, or whether it's open for network communication, mm-hmm. and then we might increase the score. We can also look at things like what kinds of authentication. Is it using Kerberos only? Does it accept other types of authentication? Does it allow anonymous callers? Those kind of things. So for a given API hit like that, we kind of add the score together and accumulate that for all sorts of other APIs, like opening a socket, reading a file, and things that don't represent attack surface, things that represent maybe something else that might be interesting from a security point of view, like is the component changing a security descriptor, an access control on a file or the registry or something like that, or is it encrypting some data? You know, what is there that's secret? Is it doing it correctly? So each time we see something like that, you know, I give it a score, and depending on the parameters, if it's encrypting it with a modern high what's the word? You know,
strong encryption versus an older.
Strong encryption,
yeah.
something like AES 256-bit.
Right.
If it's using that, then I'm likely to give it a lower score than if it's using RC4 or something like that. I mean,
Sure.
I'm hoping that we've eradicated most of our uses of RC4, but
Yes.
but something like
yes,
that.
we have.
I know it's a stream cipher, that's technical. I can't correct, so those kind of things, you know, and we can sum all of these things up for individual source files, for binaries, and into larger kind of component groupings, to the sort of granularity where we can say to one of our reviewers, this looks interesting, you know, from its behavior characteristics, from its some of the kind of maybe code complexity or source code age characteristics. We can say these together make this thing something we need to make it a priority to look at. So we can spend time doing intensive pen test work on that. And part of a kind of side benefit of the work I've been doing is that I can create a kind of a browsable map of the Windows component, so you can kind of navigate through all of the components from the very top level Windows through the major organizations, looking at which component is kind of higher risk. They're kind of colored according to risk. So when you have a reviewer that comes to look at a component, rather than just have maybe 300,000 lines of code and I don't know, several hundred source files to look at, they can have an idea of which are the interesting areas that they want to investigate.
So it seems like a lot of your efforts, you know, they go hand in hand with the rest of the SDL, you know, such as threat modeling, attack surface analysis you were mentioning, and then it seems like you're really putting some weighted scores around the security critical operations of a given component. What are some of the things, and you mentioned a side benefit, you know, as being that you can basically prioritize your efforts. So in terms of savings of effort, what do you think you've been able to achieve using these methodologies?
Well, there are a few things. So all of the components in Windows go through the SDL. Some of the operations like pen testing, fuzzing are run by the feature team themselves. Some of them are run by us centrally. So the first thing we can do is get a prioritized list of, at least for our central work, we can have a prioritized list of which are the things we want to fuzz first. If we know an RPC interface only accepts administrative connections, then maybe that's not worth fuzzing at all, because only a restricted set of users can connect to it. It also, I anticipate in the future, it's going to help our reviewers. As I said, somebody faced with 10,000, perhaps even some components, 2 million lines of code, that they can have a starting point, so they can navigate quickly to the parts that are interesting to them. They can ask the team if they see some kind of network interface being opened by a given component. They can ask them about how they're validating the data, how they're doing authentication, rather than having to either plow through all of the code themselves to discover these things or ask the team. So it saves a lot of time in that review process as well. The final thing we're hoping, this is a kind of a future feature really, it's not available yet, but as part of the sort of browsing around Windows tool, we'd like to be able to help a lot with the threat modeling effort. So this is often quite a big time consumer for teams. So if we could, for an individual component or a subset source files that a team were working on. We could highlight that team and automatically generate all of the entry points, and maybe the high security operations they're concerned that this component is doing. Then we could automatically generate the skeleton of a threat model, so they could spend their time focusing on these particular high-risk entry points and operations, rather than just trying to model the whole of their component, which is can be very time-consuming.
So it seems like this has a lot of implications, in maximizing the time spent, on security review and manual penetration testing and automated techniques like fuzzing. But it also seems to be, it's going to increase the quality of the security review coverage as well.
Yeah, very definitely, very definitely. So both in targeting the right components, right, and in when we've decided to review a component, knowing which subcomponents to go and look at first. And it also ties in with Richard Johnson's talk as another speaker at BlueHat. So we're providing kind of complementary parts of the same thing. Mine is just a very rough prototype, and my graphics programming skills and stuff like that for producing the tool are minuscule compared to Richard's. But whereas he, along with a couple of his colleagues, they're focusing on how you take a component like an individual binary and drill down and look at certain characteristics, like maybe how data flows through from entry points to certain parts of the code. My work is as a sort of precursor to that. It's the going from all of Windows to which of those components we want to look at. So in the next few months, we're hoping to kind of glue the two together, and so we can provide a kind of, from a very high level down to a really sort of microscopic view of each component.
So that seems like a really interesting tie-in with, so your work in terms of determining the appropriate places to concentrate your security efforts, to Richard's work, which is all on using visualization techniques to be able to narrow, basically narrow the focus as well. So I think that'll be a really interesting, combination of the two efforts.
Yeah.
So are there any other final thoughts you want to leave with our audience?
I guess one final thing is it took quite a while to work out some of the heuristics, and they're still not perfect by any means, but they're kind of on the way. One of the things I forgot to mention that I think it is quite important, that we spent a lot of time looking at various metrics, code characteristics and things like that, and correlating them to past MSRC cases in Windows. So you can see there, if you look at just the MSRC cases, they show a very distinct kind of skew that would, I wouldn't be so bold as to say you could predict MSRC cases, but I can predict past MSRC cases.
That's quite a prediction in
fairly
the past,
well.
Yes.
So I think so. Once we've got it up and running, possibly producing threat models, once we glue it together with Richard's kind of detailed visualization. My work is more around collecting the data and doing high-level kind of across Windows visualization stuff. Once we glue all that together, I think we have a really, really useful tool set to help us track down, the perhaps forgotten corners and security bugs that we haven't been able to come across so far.
Well, that's great. It sounds like really interesting work, and I'm really looking forward to your talk tomorrow. Thank you so much for joining us.
Thank you.